Hello, everyone. Today I would like to give you a little insight to paleolakes on Mars and why we might also call them Martian time capsules. Following the sorry. Let me check, sorry. Was the last slide, not the first slide? Here we go. Yeah. Okay. Following the presence of water is one approach to discovering potential life, as we emphasized during this conference several times. And while we do not have permanent water lakes on Mars today, we do have several known locations of former lakes, also called paleolakes, which have great potential to tell us something about the planet's history. But let's first have a look at the lakes on Earth in general. During its lifetime, a lake collects and stores information about climate dynamics, atmospheric conditions, geological influences, and biological activity, and all of this in its sediments. So in the unfortunate case that the lake will dry up, we get an opportunity to directly access this information without getting wet. Similar is true for Mars. So if we look at Mars, I believe many of us have heard at some points about the two Martian lakes currently under investigation by Mars rovers from NASA. But I want to make you aware that these lakes are only represent a fraction of the lakes on Mars. In actuality, we have more than 100 sites of these paleolakes. So we started to compiling published paleolake sites into one of our SQL databases, and currently have now about 800 locations, along with additional information about each lake of them. So those paleolakes can be further subdivided into 4 lake types. We have a network-fed open bassin lake, also shortly noted as open bassin lakes. They are identified by the presence of inlet and outlet channels. We have independent or network-fed closed bassin lakes, also known as closed bassin lakes. These lakes are characterized by having only inlet channels. And we have ground-fed and thermokarst lakes. As a side note, just to be sure, even though the term is lake, it always means it's a paleolake. So for my research, I'm focusing exclusively on the open and closed bassin lakes. The rationale behind this decision is straightforward. We lack of sufficient information about the locations of ground-fed lakes, and the thermokarst lakes we have been documented till now are relatively confined to 1 or 2 Mars regions. And I want to look at them on a global scale. So one of my objectivities is to identify global and regional trends in those Martian lakes based on location, morphology, characterization of the uppermost layer, minerals, and other factors. And currently, due to time constraint, we will only briefly look at some examples and results of the orange highlighted data parameters. So since we examine more than 500 lakes, I think there are 526 to be exactly, we used algorithms whenever possible to enhance our analysis. For each dataset or parameter, we wrote a Python script that works in a general manner as follows. In the first step, we manually georeference the dataset in QGIS. In the second step, the algorithms isolate the data value that overlay with the lake shape. Then the algorithms removes the parameter-specific threshold. In a fourth step, if necessary, the algorithm converts the data value. And in a final step, the algorithms calculate the desired statistical parameter of each lake. So where are those 526 lakes? If we look at this global scale map, we can see that the majority are located in the Noachian period. On the right side, you will find a summary of the area region we designated for the lakes according to their specific location. This image will be repeated on the result pages, so you don't need to remember the color code. So when we look a little bit closer, where are those lakes? We use the geological map of Tanaka, and based on this, we could conclude that the majority of open basalaks and closed basalaks, so 94% or 93% respectively, are found in a highland unit. Furthermore, we can pinpoint that 63% of those former lakes, or 56% of the latter, belong to the middle Noachian highland, which have an age of approximately 3.9 to 3.8 billion years ago. Additionally, we observed that 21% of both type of lakes belong to the early Noachian period. Early Noachian highland unit, which have a range of 4.1 to 3.9 billion years. So we can conclude, which is more or less what we see in the slide before, that 79% of the open basalaks and 80% of the closed basalaks dates back to 4.1 to 3.1 billion years ago. So before we proceed to the rest of the results I would like to show you today, I would like to draw your attention to our cluster analysis results. For the next couple of slides, the cluster analysis will be always presented below the histogram. And the colors matches the color that you can see on the pie chart on the right side, while each pie chart representing a mass region. So you can check based on the color where the distribution is on the mass. So to analyze the altitude-based distribution of the lakes, we used global DEA maps. And is there a problem? Okay, I just heard some.
No, everything is good.
Okay, sorry, it's just I cannot see the screen itself, so sorry. Where were we? Yeah, so the results show that 87% of the open basal lakes are located at the altitude between -3,000 to 2,000 meters, and whereby the statistical analysis indicated the regional trend. And similar is true for the closed basal lakes, where we can find about 85% who are in the same level of meters. So we can conclude most of both of the lakes have an altitude between -3,000 and 2,000 meters, and there are indicators for regional variances. When we look at the mean lake depth of them, in the open basal lakes, we find that 73% of the lakes have a mean depth value in the range of 10 to 100 meters. Furthermore, in the first statistical analysis, we only could find some altitude trends, no regional trends. For the closed basal lakes, it is noticeable that the mean depth values have a trend towards higher values by a factor of about 10. So additionally, we find regional and altitude trends. So we can say most of the open basal lakes are shallower than the closed basal lakes, and there is a partial evidence, at least, for regional and altitude variances. But it is crucial to note that there is a significant distinction in comparing open basal lakes and closed basal lakes together, because there's a slight difference how we define the mean depth, or more precisely, the surface area of a lake. For the open basal lake, the lake surface is defined by the point when water has the first opportunity to escape from the basin itself into an outlet channel. In other words, we can say it's just the value corresponds to the minimum water level at which a lake has an outflow. And in contrast, for the closed basal lake, it's determined by the maximum level, the level of water that can just be held into the basal without breaking out and forming an open basal lake. So there's quite a difference that should be reminded when comparing those results. And when we look at the circularity ratio of those lakes, the circularity ratio indicates the degree in which a lake shape resembles a perfect cycle. So this parameter here can be calculated using this formula. And a value of 1 indicates a perfect cycle, while a value of 0 describes a lake shape that does not resemble at all to a cycle. For the open basal lakes, the majority fall within the middle range of circularity ratio values. So there's not really a preference for circular or non-circular lakes. And further, we didn't find any regional or altitudinal trends. However, when we look at the closed basal lakes, we find that almost half of them fall within a circularity ratio in the range of 0.79 and 0.98, and which is definitely more circular. And statistical analysis also revealed that we have a regional trend. So in conclusion, we can say closed basal lakes are significantly more circular than open basal lakes, and regional and altitudinal variances are mostly absent. For as part of our analysis of the uppermost layer, we used available data from TAS, specific the dust cover index, which offers insights on the first few tens of microns of the lake's bed. So let's dive again into the open basal lakes. Here we can observe that 54% have a value that is in dust-free. Further statistical analysis revealed some regional and altitudinal trends, and we examine really almost the same for the closed basal lakes. There are 63% of them dust-free. So we can conclude that at least half or both of the closed basal lakes that contain mostly dust-free areas, while the data show evidence for regional and altitudinal trends. I have to admit, naturally, the regional trend we observe here is also a little bit aligned with more or less the regional trend we can observe when we look at the dust cover index from the whole planet. So there is some relation to it, of course. And as a last one, I hope we have time for it, I wanted to present you some findings from the thermal inertia data. Here we found that 76% have a value in the category of sand, and there are some regional and altitudinal trends as well. And if you remember maybe the pictures that we see from Jezero crater, they are here on this, in our data, the value can be found at the end of sand to granular boundary. And I think that's very consistent what we see from the pictures of this crater. And similar is true for the closed basal lakes. Here also sand dominates. However, the statistical analysis revealed only regional trends. And therefore we can conclude that in both types of lakes, the lake bed is dominated by sand, and the data show evidence of at least regional variances over the planet Mars. But I would like to point out here that this result does not exclude the presence of others like clay, slit, or granules or pebbles. It only tells us, or at least the data in this figure, only tell us which type is predominant. And for a next step in my project, I'm currently combining multiple parameters that we saw before. And I want to combine them to one value to see, hopefully with cluster analysis, to find more regional or altitudinal trends that are related also in combining of those parameters. Yeah, So other than that, this is concludes my presentation. I hope this has provided you with an understanding of why paleolakes on Mars are also referred as time capsules. And please don't hesitate to ask any questions. I'm happy to answer the questions via email or now in person.